For decades, scientists watched the ground in eastern California bulge, a slow, almost imperceptible swelling, pushing the floor of an ancient volcanic crater steadily upward, 33 inches in just under 40 years. To the media, to the public, the implication was obvious. A monster was waking up. A supervolcano that once buried half the continent in ash was stirring, filling with magma, and preparing to do it again. But the truth, confirmed by an incredible new discovery, was something else entirely. Something stranger, more complex, and in some ways, more unsettling. The ground was rising, not because the volcano was filling up, but because deep underground, it was dying. And while that giant was slowly freezing to death, 100 miles north of San Francisco, another one was being born. The answer to this geologic mystery lies buried miles underground, and it changes everything we thought we knew about the threats hiding beneath California. Before we uncover it, a quick question for you. What's the first thing that comes to mind when you hear the words California volcano? Let me know in the comments below. The story begins 760,000 years ago, an eruption so violent it defies modern comparison. From a single point in eastern California, 150 cubic miles of molten rock and superheated ash exploded into the atmosphere. That's 600 cubic kilometers of material, enough to bury the state of Texas 5 feet deep. The ash cloud blotted out the sun across North America, falling as far away as Nebraska and Kansas. The ground collapsed, creating a massive 20 by 10 mile depression, a caldera. We call it Long Valley. It was an extinction-level event. And then, for 750,000 years, it was quiet. A huge number of people who watch our documentaries aren't subscribed, and they'll miss the follow-up stories when the science takes another sharp turn. If you want to stay ahead of the curve and understand the real forces shaping our world, take 1 second and hit that subscribe button now. It's a small click, but it guarantees you won't miss what comes next. Let's begin. For most of human history, Long Valley was just a dramatic landscape, a quiet, scenic basin next to Mammoth Mountain. Then came May of 1980, just days after Mount St. Helens blew its top in Washington state. The ground beneath Long Valley began to shake violently. In a single week, 4 separate earthquakes, all registering above magnitude 6.0, ripped through the caldera's southern rim. The ground jolted, nerves frayed. The United States Geological Survey, the USGS, scrambled its teams. The fear was immediate and palpable. Was the 1980 Saint Helens eruption just the opening act? Was magma on the move, rocketing toward the surface in California? That week of seismic terror kicked off more than 4 decades of intense scientific scrutiny. Monitoring equipment was installed everywhere: seismometers, GPS stations, gas sensors. The goal was to build a complete vitals chart for a sleeping supervolcano. And almost immediately, the data started telling a strange story. The center of the caldera floor, a featured geologists call the resurgent dome, was rising. Year after year, millimeter by millimeter, it was pushing upward. By 2017, it had inflated by 83 centimeters, nearly 3 feet. To the outside world, this meant one thing: the magma chamber below was refilling. The monster was taking a deep breath. News reports ran with sensational headlines about a supervolcano gearing up for another massive eruption. The narrative was simple, terrifying, and it turned out to be completely wrong. The problem was that geologists were effectively trying to perform brain surgery from the other side of a locked door. Standard seismic imaging could show them that something was happening, but the picture was blurry, like a bad ultrasound. They could see the shadow of the magma chamber, but they couldn't see what was happening inside it. They could measure the swelling ground, but they couldn't be certain about the cause. Was it fresh magma influx, or something else? The question hung over the California Volcano Observatory for years. Answering it would require a whole new way of seeing. That new way of seeing came from a geophysicist at the California Institute of Technology. His name is Zhongwen Zhan. He and his team at Caltech, including lead author Ettore Biondi, pioneered a technique that sounds like science fiction. They turned the internet into a giant subterranean microphone network. The technology is called Distributed Acoustic Sensing, or DOS. The concept is both simple and revolutionary. Underneath our feet, thousands of miles of fiber-optic cables crisscross the country, carrying our emails, our streaming videos, our data. Most of these cables contain dozens of individual glass fibers, many of which are unused. Dark fiber, they call it. Jongwon John's team realized this dark fiber network was a hidden scientific instrument of unprecedented scale. Here's how it works. They tap into one of a spare fiber optic line, in this case a 100-kilometer stretch of commercial telecom cable already running through the Long Valley caldera. Then, they shoot a laser pulse down the glass thread. As the light travels, it hits microscopic imperfections in the glass, imperfections that exist in every fiber optic cable ever made. A tiny fraction of that light scatters backward toward the source, like an echo. By measuring the timing and phase of that returning light, scientists can detect infinitesimal changes along the cable's entire length. When a seismic wave from a tiny earthquake passes by, it stretches or squeezes the glass fiber by a microscopic amount, mere nanometers. But that's enough to change the path of the reflected laser light. The cable itself becomes the sensor. That 100-kilometer stretch of internet cable was instantly transformed into a continuous line of 10,000 individual seismic sensors, an array more dense and powerful than anything that could ever be deployed conventionally. They had effectively wired the supervolcano for sound. They were listening to its heartbeat in high definition for the first time ever, turning the internet into a giant spy network for volcanoes. It's a brilliant hack. I'm curious, what's the most clever use of existing technology you've ever heard of? Drop your answer in the comments below. For months, the Caltech team listened. They recorded the rumbles of thousands of tiny, imperceptible earthquakes. They watched how the seismic waves from those quakes traveled through the rock beneath the caldera. Some waves sped up, some slowed down, some were absorbed entirely. Each change in velocity carried information about the material the wave was passing through. Hot, molten rock slows seismic waves down. Cold, solid rock speeds them up. Using supercomputers to process the data from their 10,000 virtual sensors, they didn't just get a blurry shadow of the magma chamber. They built a full, three-dimensional CAT scan of the volcano's plumbing system. What they published in the journal Science Advances in October 2023 sent a shockwave through the world of volcanology. The magma chamber beneath Long Valley was not a giant growing balloon of molten rock. In fact, it was the opposite. A significant portion of it was solidifying. It was freezing. The top of the magma reservoir was covered by a thick lid of crystallized rock, about 8 kilometers thick. The volcano wasn't waking up. It was slowly, steadily going to sleep. But that created an even more urgent question. If the magma chamber is cooling and shrinking, why is the ground above it bulging upwards? Why the earthquake swarms? The answer lies in one of the most counterintuitive and violent processes in geology. The freezing of magma is not a quiet, peaceful event. Magma isn't just liquid rock. It's a pressurized chemical soup, saturated with dissolved gases like water and carbon dioxide, held in solution by the immense pressure of the deep earth. As the magma cools and turns from liquid to solid crystal, its molecular structure changes. It can no longer hold on to those dissolved gases. The water and CO2 are forced out, like the fizz erupting from a soda can when you pop the top. This process is called exsolution. A massive volume of superheated, high-pressure gas and fluid gets released from the crystallizing magma. This fluid has nowhere to go. It forces its way into cracks in the rock above, a process called hydraulic fracturing. It expands, pushing the ground upward like a hydraulic jack. That is what was causing the resurgent dome to bulge. It wasn't magma, it was the volcano's dying breath. That same high-pressure fluid is what triggers the earthquake swarms. It lubricates fault lines and pries open fractures in the crust, causing the rock to slip and shudder. The 4-magnitude 6.0 earthquakes that terrified everyone in May 1980, they weren't caused by magma rocketing toward the surface. They were caused by a massive burp of gas and fluid released by a cooling magma body miles below. As Jongwon John himself put it, we don't think the region is gearing up for another supervolcanic eruption, but the cooling process may release enough gas and liquid to cause earthquakes and small eruptions. So the monster isn't waking up. It's freezing solid, and the process is far more violent than anyone assumed. If you're finding this scientific detective story as fascinating as I do, take a second to hit the like button. And if you have a friend or family member who thinks they know California's geology, share this video with them. For those who are just finding us, I know I've asked before. But subscribing is genuinely the only way our work reaches more people. It's a huge help. The discovery at Long Valley was a masterpiece of scientific deduction. It solved a 40-year-old mystery and calmed fears of an imminent supereruption. For a moment, it seemed like the story was over. California's biggest volcanic threat was a known quantity, and it was gracefully retiring. But geology is never that simple. Because while Caltech was busy mapping a dying giant in Eastern California, another team of scientists was looking at a different part of the state, 100 miles north of San Francisco, a place called the Clear Lake Volcanic Field. What they found, published in March 2024, made the ground feel a lot less stable. They found where the new magma is coming from. While Long Valley's story is one of cooling and crystallization, the story of Clear Lake is one of active, ongoing rejuvenation. A team of researchers, including Tianzhou Li, Shucheng Wu, and Ping Tong from Nanyang Technological University in Singapore, used a different but equally powerful imaging technique called a joint state travel time tomography. It's another way of using seismic waves to build a high-resolution 3D map of the Earth's crust. Their target was the area beneath the geysers, the world's largest geothermal energy field, which sits right on top of the Clear Lake volcanic field. Everyone knew there had to be a powerful heat source down there to run the geothermal plant. What they didn't know was how deep it went, or how it was connected to the planet's engine. The picture they produced was breathtaking. This was not a fading, crystallizing magma chamber. This was a direct pipeline to the Earth's mantle. The images revealed what scientists call a multi-level transcrustal magmatic system. Let's break that down. Transcrustal means it cuts through the entire thickness of the Earth's crust. Their map showed hot, upwelling material rising from the planet's upper mantle, the asthenosphere. This isn't old leftover magma. This is fresh melt. Brand new. This mantle upwelling rises until it hits the boundary between the crust and the mantle, the moho, as geologists call it. There, it pools, creating a zone of intense heat and partially molten rock deep in the lower crust. From that deep reservoir, the magma continues its journey upward, feeding into a shallower, large-scale chamber of silicic magma in the upper crust. This upper chamber is the direct heat engine for the geyser's geothermal field. It's the furnace that boils the groundwater, creating the steam that spins the turbines and powers hundreds of thousands of homes. The discovery was profound. This is not a static, dying system. It is a live, dynamic plumbing network, actively siphoning molten rock from the planet's core and assembling it in a massive holding tank just a few miles beneath Northern California. While the world was focused on laying ground at Long Valley, science quietly revealed a far more active system to the north. One that isn't just making the ground swell, it's actively being supplied with new material from the mantle. Today, the implications are enormous. It reframes our understanding of volcanic risk in the state. California isn't just home to old, fading volcanoes. It is a place where new volcanic systems are being built, right now, under our feet. This constant supply of heat from the deep earth does more than just pose a long-term volcanic hazard. It's also creating a modern-day gold rush. The magma itself has become an economic engine. At the geysers, that heat is harnessed to generate about 725 megawatts of electricity, enough for a city the size of San Francisco. It's one of the most successful renewable energy projects on the planet, all running on the heat from a magma chamber that is actively being refilled. A similar story is unfolding 500 miles to the south at the Salton Sea. Here, in a blistering desert basin, another shallow magma body is driving a different kind of boom. The Salton Sea sits within the Salton Trough, a tectonic pull-apart basin where the Earth's crust is literally being ripped apart. This thinning crust allows magma to get incredibly close to the surface, creating another intense geothermal hotspot. For years, companies have drilled down to tap that heat for electricity. But now, they're after a different prize hidden in the superheated, mineral-rich brine that circulates through the hot rock. That prize is lithium. The geothermal fluids beneath the Salton Sea are saturated with lithium. It's the key ingredient for the batteries that power our phones, our laptops, and, most importantly, our electric vehicles. As the world transitions to green energy, demand for lithium is exploding. The problem is that most of the world's lithium comes from environmentally damaging evaporation ponds in South America or hard rock mines in Australia. But here, at the Salton Sea, companies are pioneering a new method called direct lithium extraction, or DLE. They pump the hot brine up from the geothermal reservoir, use a chemical process to pull the lithium directly out of the fluid, and then inject the rest of the water back underground. They are, in effect, mining a volcano for the building blocks of the green economy. The area is already being called Lithium Valley, and analysts predict it could soon become one of the world's largest sources of lithium, all powered by the heat of a shallow magma intrusion. A geologic feature that represents immense destructive power is simultaneously being harnessed as a critical resource for our technological future. It's a paradox that lies at the heart of California's new geologic reality. So while one supervolcano is loudly, violently freezing to death, another active system is quietly pulling new fuel from the mantle, and yet another is powering a 21st century resource boom. California's identity has always been tied to the San Andreas Fault. Earthquakes are the known enemy, the ever-present threat that shapes building codes, insurance policies, and the public imagination. But this new science reveals a second, hidden front in the state's geological war. A vast, complex network of magma chambers, conduits, and heat sources that are far more dynamic than we ever realized. The USGS already classifies at least 7 volcanic areas in the state as high or very high threat. Mount Shasta, a towering stratovolcano in the north, the Lassen Volcanic Center, which last erupted just over a century ago, Medicine Lake. And now, the true nature of Clear Lake and Long Valley is coming into focus. The story of California's magma is not one of a single ticking time bomb. It's the story of a whole ecosystem of volcanic processes, some being born, some dying, some being repurposed. The fiber-optic spy network at Long Valley proved that the bulging ground was a sign of freezing, not filling. The deep seismic imaging at Clear Lake proved that a direct mantle connection is actively feeding a new system. These were not conclusions anyone expected. They were revelations made possible by technology that didn't exist a generation ago. We can see deeper now. We can map the plumbing. But seeing the system doesn't mean we can predict it. Understanding the process of a magma chamber freezing is not the same as knowing exactly when the next gas-driven earthquake swarm will hit. Mapping a transcrustal magmatic system doesn't tell us when or if that magma will ever find a path to the surface. We've gone from being completely blind to having a blurry roadmap of a world that is constantly in motion. These discoveries don't eliminate the risk, they redefine it. The irony is that for 40 years, the wrong volcano got all the attention. The public feared the super eruption at Long Valley, a scenario that new science says is unlikely anytime soon. All the while, the truly active system at Clear Lake was just beginning to reveal the scale of its power. We were watching the wrong door. This is the constant challenge of geology. The Earth operates on timescales that are hostile to human comprehension, but it delivers its consequences in moments of shocking speed. So while one system is cooling, another is actively being fed from the Earth's mantle. This story is always changing, always evolving. I know, this is probably the 3rd time I've mentioned it. But a shocking number of you will watch this entire documentary and simply forget. If you value this kind of deep dive and want to support our next investigation, please hit that subscribe button. It makes a bigger difference than you can imagine. The science has given us an unprecedented look into the underworld. We can see the heat from the mantle bleeding into the crust. We can watch as liquid rock turns solid and exhales gases with enough force to lift mountains and trigger earthquakes. We can even turn that heat into electricity and mine it for the minerals that will build our future. We have peeled back a layer of the Earth and found a system more active, more complex, and more deeply integrated into our own lives than we ever thought possible. But the final question remains, and it's one that no seismic array or supercomputer can answer. For every mystery we solve, we uncover a dozen new questions. The picture is getting clearer, but the future is not. We can map the monster. We can take its temperature. We can even put it to work. But we can never truly know what it will do next. California is not just earthquake country. It is